Hello again. Here we are discussing about the development of tooth. And if you have not subscribed to my channel, please do subscribe and also like, comment and share. Here is the developmental stages. These are initiation, bud stage, cap stage and bell stage. Bell stage is again divided into early bell stage and advanced bell stage. Now here is a diagrammatic view of the stages. The first is initiation, where how the primary epithelial band forms and how the placods formation occurs. The bud stage, cap stage, early bell stage and advanced bell stage. In my previous videos we have already seen how the dental lamina forms, also the bell stage and cap stage. Now we'll see how the bell stage goes. The bell stage is divided into early bell stage and advanced bell stage. Now in early bell stage we can see the two process, that is morphodifferentiation and histodifferentiation, which we'll talk about. And in advanced bell stage we'll see the apposition and the root formation. Now coming to the early bell stage at about 14th week, as invagination of the epithelium deepens, its margins continue to grow and enamel organ assumes final morphological shape. Now the ameloblasts and odontoblasts have assumed their distinct phenotype, which is from the inner enamel epithelium and dental papilla cells respectively. Now the folding of the enamel organ caused different crown shapes due to different rate of mitosis and differentiation time. So here the enamel organ assumes the final bell shape. Now if we take a greater picture of the early bell stage, these are the inner enamel epithelial cells, which are tall columnar cells, and this will give rise to ameloblasts. And these are the outer enamel epithelial cells, which are the cuboidal cells. This is stellate reticulum, and here is the stratum intermedium cells, which are spindle shaped cells. Now this is the dental papilla, which will give rise to odontoblasts, and this is the dental sac. So here inner enamel epithelial cells push out in enamel organ in form of cusp tip, and the growing dental papilla cells exerts pressure on inner enamel epithelium, which is countered by fluid of stellate reticulum. Now we talk about the stellate reticulum cells. First they expand and then collapse before the enamel formation, and they decrease the distance between the ameloblasts and the nutrient capillaries near the outer enamel epithelium. Here is the future DEJ or dentino-enamel junction, and the cell differentiation proceeds cervically. So the inner enamel epithelial cells and the outer enamel epithelial cells, they meet cervically to form the cervical loop. This area is called as the zone of reflection, and here there is intense mitotic activity in this area. Now what happens to dental lamina? They break up in small islands of epithelial cells, and the remnants are called as cell rest of Ceres. Now we're coming to the dental papilla. The cells are divided into two types. The first one is the peripheral cells. The ameloblasts induce the peripheral dental papilla cells to differentiate into the odontoblasts. They are cuboidal to columnar type. And second type of the dental papilla cells are the inner cells, which serve as the primordium for the dental pulp. Now the dental sac or dental follicle is divided into three layers, that is inner cellular layer, middle loose connective tissue and the outer fibrous layer. Now coming to the advanced bell stage, at about 18th week of pregnancy, we know the enamel organ is separated from dental papilla by the basement membrane, but just prior to the formation of enamel, it's called as the membrana preformativa, and it's very important from exam point of view and viva. Now here in advanced bell stage, there is process called apposition, where the enamel and dentine layer is let down by the mechanism called as reciprocal induction. So what is this? Now what happens is the ameloblast induce the differentiation of dental papilla cells into odontoblasts. Now the odontoblast will form the dentine as a layer along the future dentino-enamel junction in the region of future cusp tip, and this proceeds pulpally and apically. Now what happens is then it will give signal to ameloblast to lay enamel matrix over the dentine in future incisal or the cuspal area. Now this process will proceed coronally and cervically from the DEJ to the surface area. Now we'll see the root formation. Once the enamel and dentine formation reaches the future cement-to-enamel junction, the root formation starts. The inner enamel epithelium and outer enamel epithelium meets to form the cervical loop, which extends by proliferating, forming Hertz, that is Hertwig's epithelial root sheath. Now the inner layer cells, they remain short and they do not produce enamel. They induce the differentiation of odontoblast from the dental papilla cells to form the radicular dentine. When the first layer of dentine has been let down, the Hertz loses its structural continuity and close relation to the root surface. Now, so the remnant persists as the epithelial network of strands or clumps near the external root surface, and these epithelial remnants are called as the cell rests of Malassez. Again, it's very important. Now, prior to the root formation, the Hertz forms the epithelial diaphragm in apical direction, and it bends at CEJ in horizontal direction, narrowing the wide cervical opening of the tooth germ. Now, as the Hertz proliferates, the pulp's connective tissue accompanies in area adjacent to the diaphragm. Free end of the diaphragm, they doesn't grow into the connective tissue, but the epithelium proliferates coronal to the diaphragm. Now at the same time, the dental sacs connective tissue proliferates and invades Hertz, dividing it into network of the epithelial layer. Now Hertz degenerates and moves away from the dentine surface so that the connective tissue of the dental sac come in contact with the dentine surface and differentiate into the cementoblast. Now they form the cementum layer over dentine, and rest of the dental follicle cells, they become fibrous for the periodontal ligament formation. And the wide open apical foramen is gradually reduced by the position of dentine and cementum to the root apex. And in multi-rooted teeth, the epithelial diaphragm develops tongue-like extension which grow inwards and divides the root trunk into 2 or 3 hollow parts which will form the roots. So now we have discussed how the root formation occurs. And this was all about the early and advanced bell stage. And stay updated for more videos.